key topic power, and then a real world EDA problem statement. So if I start with what is series and data frames, so series is nothing, it's just a NumPy array. And what it does have is it has labels to your array. And a data frame is a multi-dimensional NumPy array with labels on rows and columns. You can see what do I mean by labels within a while. So, again, in order to use pandas, you need to import it, import pandas as PD. PD is again like globally most widely used alias. So we'll start by creating a series first. So series can be created using anything like Python list or dictionary or NumPy array. So if I have a list and I use dot series method, which is offered by pandas, what I see here is it returns me these numbers, but what you also see is that on the left hand side, it has this number 0, 1, 2, 3, 4. So what it did was it indexed these, like it provided labels. So the first number has the label 0. Suppose if we want to give our custom labels, we don't want it to be 0, 1, 2, 3, 4, but we want to specify like what should be the label. We can do this using the index parameter and we can pass in the index. Just make sure that your index list which you pass is of the same size or the same length as your list which you're creating series. So if I run this, what you observe is against Monday, like or it's labeled as A, Tuesday is labeled as B, and this is what we get. One thing to notice is in case of numbers, you see it's of integer data type, but in case of strings, right, Monday is a string, it's of object data type. So in pandas, strings are treated as object data type. Now, further continuing, suppose if you have like data or say you have your country and the country code, right? So you can simply again like create a series which will have the country code as the labels and the country name as your data. So these are like few examples of series. Now we'll see how can we create a series for NumPy array. It's very same. You just have your array and you just pass in the array to the series method. And you can do similar things what we did for the list for the NumPy array. Nothing changes. It's very simple and similar. Now, we don't use series that often, but it is worth knowing it because series form the basis of data frame. So likewise, we studied series. It's a one-dimensional array. It deals with one-dimensional array and provides labels. Data frames, what they do is it deals with multi-dimensional array. And usually in the real world, when we deal with data, it will have many rows and many columns. So in this case, I've taken the names of the country and their code. So I have a Python dictionary, which has the name of the countries and the codes as the key. And if I want to create a data frame, I use pd dot data frame method and I just simply pass on my dictionary, right? If you run this, what you observe here is you get a data frame and see how beautiful like it looks. So understanding this is difficult, but understanding this, what data is it? It's very simple. It's clearly presented in tabular format. So you see you have name and you have codes. So these are the labels which I was talking about. It's just a NumPy array, but it has these labels for the columns and this 0, 1, 2, 3 labels for your rows. If you want to create like you have an array and if you want to give the column names by yourself, you want to customize the column names or you want to change the column names, you have dot data frame method and you have a parameter called columns where you can specify the column names. If you run this, you see the first column is labeled as column 1, the second column is labeled as column 2, and the third column is labeled as column 3. So this is how do we create a data frame. Second, if suppose if you want to create a data frame from series, so that is even possible. So you can convert a series to data frame. So the first, what we're doing is we have this dictionary and we're creating a series. Then we are just simply passing this series to the data frame. And what we get in return is a data frame, which has this as your it has single row and single like it has multiple rows and single column, and the column is labeled as codes and the rows are labeled with the name of the countries. Now to this data set, suppose if you want to add another column. So you want to add another column which tells you the population of each country. So you can like these are not realistic numbers. So just consider them for example. How you can add a column is simply just uh, type in your data frame. So we have stored the data frame in a df variable and you specify the name of the column within square brackets and then you pass on your list. So this list is basically the rows, like the value for each row. And you should again make sure that it has the same number of rows as in the existing data set. Otherwise, it's going to give you an error. You run this, you see we have a new column called population, and we have all this data. So it is really simple playing with data or the data frames or data sets, adding columns, removing columns through Pandas. It makes all this tedious tasks very easy for us. Now, suppose if we want to remove a column. So we added a column, but if you want to remove a specific column, maybe while we're performing data analysis, we found out that this column is not useful for building our model. So how do we remove that column from our data set? So we use the drop method and we specify the axis one. So like always remember axis 0 is for specifying if you want to remove a specific row, and axis 1 signifies removing a particular column. So what it will do is it will remove the column which has column name as population. Run this, you see the population column is gone. If you want to access the names of all the columns, so see this wasn't in place, like it will just return you back. But if you want, it should happen for the real data frame. You need to use this in place is equals to true, but I'm not doing it right now. Otherwise, it will modify my original data frame. What we usually do is when we perform such dropping operations, we simply create a copy of our data frame so that we don't lose our original information. Now, if you want to access all the column names, you have dot columns method or method offered by the pandas data frame object. So you just do df dot columns and you see you have both the column names here. If you want, again, there is another method called keys. So if you run this, it will return you the row data. Yeah, if you do df.keys, it will return you the labels which we were using for the row. So these are basically the indices which I was using. So here you get these row names. So for accessing columns, you have dot columns, and for accessing row labels, you have dot index method. Now coming to again like performing data selection and indexing, we can simply like indexing. I already told you we can use index parameter. We can specify the indexes uh, like similar to what we did for columns, we specified the column names, we can specify the index as well. And we see it has given these indexes here for our data frame. Now, if you want to access say a particular column, what it will return is it will return that particular column as well as the index of the column. Now, suppose what you want is you want to create a uh, new column called country, and you want the name of the country to be capitalized. So you can simply access this name, like all the country names using name column, and you can pass in the column name, and you can use string dot upper method, and you can store this in a new column called country. And if you run this, you get a new column called country, and it has all the country names in capital. So, like these are small things which we'll be using quite often, or it's used quite often. I'll skip through this because it's again like very repetitive. I've already covered. Now, if you want to access, suppose only the first two rows, like I told you, we can in like we used to do in NumPy, right? We will just simply specify the starting range and the ending range, and ending range is again not inclusive, so we'll get the first two rows. So it's 0 and the first row. Similar to what we do here, we have dot loc and dot ilog functions. The dot log function, if you pass in your index, it will return you the data frame with having like it will return you the row which has this particular index. In our case, if you see the first row has this index A. It returns me the first row and all the column values, like it has USA1, it returned me that. If you want to access within some specified range, if you want to access all the rows after between index B to D, you can just use this method and you can get all the indexes. Again, this like all the rows. Again, it's the same. Here you're not specifying the starting point. So what it will do is it will assume the starting to be 0 and the ending to be the index specified here. Now, ilog is similar to LOC, and it does returns us the same. The difference lies is that here, if you observe in a log function, you were getting like the name and the data type as well. Here also, you're like it's just same, and it's ilog is more commonly used. It will allow you to access even rows and columns, and we'll see further how do we do this when we're using the real world data set. Now, coming to conditional selection, similar to what we learned in NumPy, we can access our particular values from our data frame using these conditions. For example, I want to get the rows or the data where the country code is 49. Simply specify, I simply compare um, all the rows against the condition like which have the code as 49. It will return me that particular row. if I want all the country names or my entire data which has country code lesser than 250. If I run this, I'll get all the country information which have the code lesser than 250. So like these are again same, and I can again use AND operator to club multiple conditions. Other than this, there are two other operators which are isn't and where, and we quite use them a lot. So what does isn't offers us is, suppose if you have an existing array, right? You want to you want to see whether your data frame has the values that are present in this list. So you have this list and you use dot as a function and it compares whether each of the element, like whether this value was present in our data frame and is it present in this list. If yes, it will return you true, and if not, it will return you false. So it's kind of logical selection, and it would make you more like it would make more sense when we'll be dealing with the real world data. So this is all same. I would skip through it fast. This is like comparison operator. Now, what where condition allows you, like whatever place this condition you satisfied, if it is getting satisfied, it will return you the number. But the places where this condition is not getting satisfied, it would replace by the second argument which you passed on. So in this case, it is 0. So wherever the data set has the value greater than 4, it will give you like that number, and in other places, it would return you 0. Now it's just same. Now iteration, I'll cover this in example. I have added this in this collab notebook so that you can go through it in detail in when you get the access to the notebook. But I'll come straight forward to how do we deal with missing data, and can go through this in detail. If it's wherever it will come, I'll explain it to you. So now dealing with missing data, the most common thing which we come across whenever we are using a real world data set, we have a lot of times where we don't have any data available or we have missing data. So how do we check whether our data frame has missing data? So suppose I created a data frame which has some missing values, and in order to have missing values, we use np.nan. So if any value is assigned nan value, it's just like your data is missing, similar to your missing data. So if you use dot is null function, what it does return is wherever the value is null or the data is missing, it will return you true. So here you see you get true at these places and false at the other places. And if you do dot is null dot sum, what it does is it gives you it groups according to the column, and it tells you like which column is having how many missing values. But in our case, column 2 has 2 missing values, so it does returns us 2. So this is how we check for the missing values. Another way we use this is like it's just reverse. We use not any function. So what it does it returns true to us in case the number is not null. And if it is null, it will return as false. It's just opposite of is null, and it's like very intuitive from the name, not any, and is null means whether the number is null. So you can remember it by remembering these names. Now, how do we remove the missing values? So there are certain methods which we adopt to deal with missing values, and one of the methods is like to simply drop in the missing values. So for that, what it does is like it will remove the rows which have missing data. It's not widely used, but yeah, it is one of the ways how to deal with missing data, and there are certain other ways which we'll be learning tomorrow. So how do we deal with this is we use drop any function. If we use the data frame and type dot drop any, it will drop all the rows which had missing values. So in our case, it dropped me all the rows, and now the data frame has only one row. If you want to not remove rows but rather columns which have nan value, for example, if there is a column, for that column you only have very less, like 20% of the data, and 80% of the data is missing, and that column is not even helpful for you in building the model. So you can simply drop that column out. So you can specify the column name and then use dot drop any function, or you can specify the axis. So you can drop it by axis as well. So if axis 1, again, it's like for columns. So this you can execute and check. Now, as I said, dropping the missing values is one way. Another way is like we fill the missing values. We don't drop the rows which have missing values. Rather, we replace it by some values, say which are for that column, what is the most frequent value or what is the average value. So we replace missing values with such kind of values. So suppose if I want to replace all the null values with a particular number, say here 10 in this case. we just do type the data frame and dot fill in a function. If I run this, you see wherever there was null, it got replaced by the number 10. If you type in anything else, it will replace it by that. So this is how we use fill in a method. Now I'll skip through this. These are like whatever I'm telling you will be like is the most commonly used, and the other things are like lesser used, and so you can read it. So I'm skimming it through. Now we have like more functions and operations which we can perform. So suppose if you have this data frame or the data set, if I print this, so what do we have is so it's df4. We have the product name, we have the order number, and we have the total quantity. Now, suppose if you want a summary of your entire data frame, so how would you get that? So for that, Pandas offers a .info function, which gives you a detailed summary of the data which you have. So in our case, like if you use .df4.info, what you get is the column name. What is the count of the rows which are not null? So here, if you see the not null count is 3, and the total entries are 3. You see there are no null values, and you get the data type of the columns. So if you run this info method, you get the entire idea about your data set. Similarly, we have dot columns and dot keys method, which we've already covered. I'm skipping through it. Other than this, you have dot head and tail function. So what head does is, as the name specified, it returns you the top n rows, and n is the number you specify here, how many rows you want. It returns you the top n rows, and the tail returns you the last n rows. And again, n is the number you specify here. Then here in this case, I've specified the number 1, so it returned me the top one row, like the first row. If I specify tail 1, it returned me the one row. Now, why do we use it? We use it to understand the data. What is the data set? What kind of values do we have? So we can like simply do df.head and print the first 5 rows and go through the data to understand it well. Now, if you want to know the size of the data frame, you can again do it, or the number of elements by using dot size method. If you want to know the shape, like the number of rows in column, you can use dot shape method. And again, you want the number of rows in a data frame, you can use shape like 0. This is 0, the number of rows, and this is 1, indexed 1, which is the number of columns. Now, suppose if you have your data set and you have many products, but you want to know what are the unique products which I have in this data set. So we can use dot unique function. It will return us all the unique values. So why do we use it? First of all, we get to know what are the unique values for that particular column, and we also get to know whether we have any null values or not. So if we have null values, it would return us NaN as well. So if you want to get the number of unique values, you can get that as well by using n unique. If you want to get the count of each value, like in a column, so you can check, you can get the count as well. So here we have only one short, one boot, and one back, so it gave us the count. So these are same as like applying the squaring operations and using just lambda functions. You can go through this. We can even sort the values in our data frame using sort values method. So if you specify the column name and you use this method, it will return us the data sorted by the order number. And if you want to reverse sort it, you can set ascending to false. If you want the number in like decreasing order, so you set ascending to false. Now we have certain aggregation methods as well. And for example, if you want to understand a data well, we use dot describe method. So it gives us the entire mathematical summary of our data. So for each column, it will tell you what is the count, what is the unique count, what is the mean for this, what is the standard deviation, what are the quantiles, what is the minimum value, what is the maximum value. And as you do some advanced data analysis, you will find all this information to help very helpful to gather the insights from your data. We can, so here in this example, you see that it has column names here and the metrics here. So it might be difficult to read for some of the few people. So we can like simply use dot transpose. So it just makes the rows as columns and columns as rows, and this becomes more readable to us. Now, if you want the most occurring or the most frequent value for a particular column, we can use dot mode method. If you want the maximum value for a particular column, we can use dot max method. We can specify the column name in dot max. We want to get the minimum value, we use dot min method. So like these are different methods. You can, again, like these are same as what we covered in NumPy, so you can all go through it. So if you use dot sum, what it will do is all the values, all the row values for this particular column, it will do a sum and it will return you to use. So you see, like a lot of manual things are eliminated. So all these things we'll be using a lot. Now, group by is again most widely and commonly used. So if you have your data set and if you want to suppose group your data set by product name, you see there are repetitive product names. So you have short at multiple places, you have boots at multiple places. If you want to group them by product name, you simply type in dot group by and you specify the column name. And then if you want to perform some operation, like based on that, you want to access them by product name and you want the mean value, like the average orders placed for ankle or like average orders placed for, say, boots. So you can simply use the mean function. So you see the average quantity, like average order placed for bag was 9. And you see the maximum number of orders, or you can see the greatest averages for t-shirts. So by this, you can understand like the t-shirt was the most selling item in your shop. So that is how you like understand, and we'll see from the real world data set as well. So like we got the mean, we can even sum, so we can get the total quantities which were sold. Similarly, we have max and min, and it just remains same. So if we want to perform aggregation, like if we want minimum, maximum, and sum for each column, so we can simply do group by and then we can use aggregation property like dot aggregate. So what it does is for each product name, it will aggregate the other column values and it will use these operations which you've specified. Now I'll go to the EDA part. So yeah, okay, let me cover this as well. So suppose if you have multiple data frames, or just for an example, if there are multiple sources for your initial data and you have created multiple data frames, you have made your data ready for building the model, but you have different data frames. So how do we combine those data frames? So for that, we have this concatenation operation. In this case, I have three data frames which have same number of rows and columns. So this is necessary, you should have same, otherwise it will like result in NN values. So you use concat method, you simply given your data frame names as a list. So you see it added data frame 1, data frame 2, data frame 3, it combined the data of all these data frames and you get this big data frame. If here what it happened is it placed df1 first, df2 then and then df3. But if you want it to happen like row wise, so it will concatenate row wise. But what happens is it creates multiple columns like of each data frame. And so for the first data frame, you only have values for this. So it will assign like null values to the other columns. It is also required like based on our business requirements in use case, we do these kinds of operations. Now I would skip through this. You can this merge operation is similar to SQL joins which we perform. So if we want all the data, like the entire data from our first data frame and only the data which is common to the first and second data frame, we can use left join. And if we want all the data, entire data from the second data frame, and we want only the common data between data 1 and data 2, we can use right join. Suppose if we have two data frames and we want only the common data in those data frames, so we can use inner join. So here, like I have very well documented everything, and you can go through this and you can go through the official documentation. But just want to keep this session short because I have a visualization to cover as well. So now, I guess, yeah. So we'll be going through, like I said, real world exploratory data analysis to understand whatever we learned till now better. So for that, we're using California housing data sets. It's one of the most commonly used data sets. So for using this and simply downloading this, the data is present at this link and simply downloading that data set. So now this data set, you see, it's a file which is of .csv type. Now, how do we open this file, or how do we create a data frame out of this CSV data set? For that, Pandas offers us a function called read underscore CSV. So if you do pd.read underscore CSV and you specify your data set, what it does is it accesses the entire CSV data and it creates a data frame out of it. So as I've run this, I have housing.csv present here at my runtime. It got downloaded. So if I do this, then if I run this, it will create a data frame. And how can we check this? We can simply do data.head. So by default, head returns the first 5 rows. Now, you never saw this data before, and you used dot head and you got access to the first 5 rows. Now you can see like what this data set consists of. So it has this like longitude, latitude. It has median age of the people, it has total number of rooms, total number of bedrooms, what is the population, what is the household, what is the medium income, and what is the location of the house, like whether it's near to the ocean or not. So just by seeing this, you get a lot of information, like what is the data. Now you can print the type of the data. Now suppose one of the most common thing which we use is we perform some analysis on our data set and we want to store it back. We want to store our process data into a CSV file. So for that, we just simply do .to_CSV method. We specify the name of the file and we don't want indices to exist. So we just specify it false. If you run this, it will create housing underscore dataset.csv file. So we can also create an Excel file instead of CSV, we use .to_Excel. If I run this, it will create an Excel file here. You see it got created. So if you check this, you'll see Excel file. It got downloaded in my local system. So yeah, this is how you create an Excel file or you store your process data into files. Now we can, similar to how we read CSV data, we can read Excel data as well. So for that, we have read underscore Excel method, like we had a read underscore CSV method. So this is another information. Now we'll perform some EDA. So for performing EDA, I'm using this wine data set. So there's some information about this red wine quality. We are downloading this data set. You see here, I have this data available with me once I use this code. And then we'll create a data frame. So here I created a data frame and I'll use .head method. So if you run this, you see there are some certain properties and then we have the quality of that wine. So the higher the number, the better is the quality. So likewise, I access the first 5 rows. I can access the last 5 rows for this data set as well. So I'm using the tail function. So what do you observe here is like there's some 1598 rows here present. Now you got the data set, you saw the rows, but it's difficult to have the entire summary, right? You want a summary of the entire data set. So for that, we have this .describe method, or first thing like which we can do is used wine underscore data.info, and what it will tell us. So it will basically tell us all the columns which we have and all the not null values which we have and what is the data type of each column. So you see all the values are floating, only the qualities of integer data type. Similarly, you can get the mathematical or the statistical metrics like what is the mean, standard deviation, and what are the quantiles, what is the maximum and minimum value. So you can get all these values and we'll see how do we like use it and how do we extract information from it tomorrow. So again, info I've covered, describe I've covered. We check whether our data set has some null values. So for that, as I told you, we use is null.sum. So if we check this, we see that none of the columns have null values. So it's like a cleaned data set. We don't have any null values. Now we want to check like what is the quality, like what kind of quality the most wines have. So if we run value counts, we see that we have mostly good quality wines. So it has a rating 5, and there are 681 wines which have good quality, and we have very lesser wines of say less good quality or bad quality. Like we can even do group by. We can group by the wine data based on, say if you want to group by the wine data using some certain column values, so we can do that as well. It provides you the entire grouping. I cannot see it right now because it has many rows, so it just dashed them out. So yeah, this was all about pandas, and I hope you've got to learn quite a lot. It was a very extensive notebook, and I'll provide the link so that you can go